Okay. So we are looking at properties of segments today. We want to be able to identify the properties, segment properties, but also properties of congruence and equality, which kind of go hand in hand. So we still have our properties of equality that we use with algebraic proofs. They also work when we're talking about segments. So we can use the same properties, the addition property of equality, subtraction, multiplication, and division. All of these properties still apply, and we can still use them when we're talking about geometric shapes and figures. Okay. So just to review, what's the reflexive property?
What it reflects.
What it reflects. Yeah, it might be like algebraically we might have like, well, 7 equals 7. That's always a true statement. It's a reflection of itself. It's the same thing. In geometry land, we might have segment BC is congruent to segment BC. It's congruent to itself, okay? That is the reflexive property. So it works both with algebra statements and it works with geometry statements as well, okay? Angle H is congruent to angle H, all right? What's the symmetric property? The spin around property. It spins around. So, yeah, so if we have x equals 3, it's the same as 3 equals x. So if we spin them around the equal sign, it says the same thing. So that's the symmetric property. And again, that is important for us because our proof has to exactly match. And even though we understand that these two things are equivalent, when we're doing formal proofs, they have to be identical. So we have to take that step to spin things around on occasion. Okay. What's the transitive property? That's a new one. So it says if A equals B and B equals C, then A equals C. Yes, or C equals A, but yeah. Then A is equal to C. So it has this sort of a linking. I like to think about it as like a chain linking sort of thing. A is to B and B is to C, then A must also be to C. Like it's sort of a nice little chain. All right, so that is the transitive property, and we use that also a lot in our geometric proofs as well. Okay, so all of those properties can, oh, well, she says they can only be used with equal signs. That's interesting. That makes sense if it's called the property of equality. But we do have some properties of congruence that can be applied with the congruence symbol. So the reflexive property of congruence. So it's the same here. This is the property of equality, but it's the same is true if we have congruent things. So for any segment AB, then segment AB is congruent to segment AB. So it is exactly the same as the reflexive property of equality, but since we have a congruent symbol here, we call it the reflexive property of congruence, okay? But that's okay. It's still the reflexive property for us either way. It's fine. The symmetric property as well, if segment AB is congruent to segment CD, the symmetric property says we can spin it around. Then CD is congruent to segment AB. So again, symmetric, we can still spin things around. And again, this is the symmetric property of congruence, but let's not split hairs, shall we? This is the same thing. So the transitive property of congruence, very similar to the algebraic property, transitive property. But again, if we have segment AB is congruent to segment CD, and let's pretend segment CD is congruent to segment EF. So again, we've got this sort of chain link going on here. AB, CD, CD, EF. Then what can we conclude? Yeah, segment AB gets to link up with segment EF. So segment AB is congruent to segment EF. So again, same properties. We can just replace that equal sign with a congruence, and so they all still work with our geometric figures. All right, so we do have some extra definitions that we want to make sure we're really clear on. Any questions on the reflexive, symmetric, transitive? Was it good? Yeah? Okay. All right, so we have some definitions here. The definition of congruence, and again, this is kind of a nitpicky thing for proofs, all right? We have to be pretty careful when we do proofs. Segments are congruent if and only if. That's a biconditional statement there. Segments are congruent if and only if they have the same measure. So what does this mean? This is a forwards and backwards statement. So forwards, it says segments are congruent.
Any sophomores who need your pictures retaken or taken, please make your way to the auditorium lobby. Thank you.
Any sophomores? Anybody got to go? Okay. So segments are congruent. So if two segments are congruent, let's say if segment AB is congruent to segment CD. If we have congruent segments, then they have the same measure. So how do we denote things when we're talking just about their measures? We can talk about their measures are equal. AB is equal to CD. When we drop the segment bar notation, this is talking about the lengths are equal. And so we can say that the whole figure itself is congruent. When we drop the notation, we're saying the length of each piece is equal to each other. So lengths are equal, but the figures themselves have to be congruent. If I do the converse of this statement, so if segments have the same measure, so if their measures are equal, so if AB is equal to CD, then, if their measures are equal, we can say that the segments are congruent. So segment AB is congruent to segment CD. And so that's the definition of congruence. If segments are congruent, their measures are equal, and vice versa. Okay? Definition of congruence. All right. We also have midpoint definition. The midpoint of a segment divides a segment into two congruent parts, or two equal lengths. So if we know that M is the midpoint, what can I mark on my picture? If M is the midpoint, what should I mark on my picture? AM equals MB. We get two congruent segments, which also means then AM is equal to MB. The length of segment AM is equal to the length of segment MB. So if midpoint, then two equal or congruent. We could go either way. Definition of midpoint. Okay, questions on those? We're good, right? We've seen all this before. It's kind of like a review day. All right, kind of nice. All right, we do have some good postulates here. What is the segment addition postulate? Little part plus little part equals whole thing, right? Good, very good. All right, so it says if A, B, and C are collinear, so B is between A and C, and they're all on the same line, then little piece, AB, the length of AB, plus the length of BC is equal to AC. Little piece plus little piece equals the whole thing. AB plus BC equals AC. So very good, we know that postulate. We have to use that on occasion as well. All right, so these are all of our properties of congruence, definitions, and postulates today for segments. specifically. Now we want to just get some practice in to see what is what here. Justify each statement below using a property of equality, property of congruence, a definition, or a postulate. Okay, I have a segment equal to a segment itself, really. That's funny. All right. So how come I can jump to they are congruent? They do. It's kind of like the same thing. It has a special name, though. What allows us to jump between equals and congruence? Back a page. The definition of congruence allows us to jump between two things being equal and then their figures being congruent. So that reason is definition of congruence. If they're equal, then they're also congruent. So that is the definition of congruence. You know, sometimes I don't really like to use definitions. I'd rather like write it out in words, which I think is also perfectly acceptable. Like if two things are equal, then they are congruent, which might be a little bit more specific, okay? If two things are equal, then they're also congruent, and we could reverse that if we needed to. It says the same thing. So either one of these, definition of congruence, or you can do an if-then statement, or even, which would be better, the biconditional statement. We could just say equals implies congruence with the double arrow. That is the biconditional statement. So we could do that as well. And that is the definition of congruence. We got the double arrow thing going on. That might be an easy way to get it said without having to remember definition of congruence, but that's up to you. All right, if K is between J and L, so we've got this J and we've got this L, and K is somewhere in between them, then how come JK plus KL is equal to JL? Segment addition postulate. Segment addition postulate. Seg add post. Segment addition postulate. All right, how come segment EF is congruent to segment EF? Reflexive, yeah. It is the reflexive property. It's showing its reflection. That's how I remember it's reflexive. Okay. Let's see. Looking at number 4, I have this statement that RS is equal to TU. So I have the lengths of two little segments are the same. And then, what did they do? They took our RS and they added an XY to the left. They took the TU and they added an XY on the right. What did they do there? Yeah, they just added the same thing to both sides. They added, that is the addition property. They added the same thing to both sides, the addition property of equality, if you wanted to be really formal. All right, if AB is equal to DE, then why is DE equal to AB? Symmetric, we're just spinning it around. So that is the symmetric property. All right, very good.
Any freshmen that need their pictures taken or retaken, you can do it at the auditorium, freshmen.
All right, this says why is the midpoint of segment XZ? Again, sometimes I think it's really helpful to make a little picture. So here's segment XZ, and then I know that Y is the midpoint. What does that mean if I know Y is the midpoint? Yeah, I get two equal segments, or the lengths are equal. So XY is equal to Y. How do I know that? What has allowed me to make that conclusion? The definition of midpoint. Yeah, the definition of midpoint. Definition of midpoint. Very good. All right, number 7. FG is congruent to segment HI, and HI is congruent to JK, then how come FG is congruent to JK? What property is that? Transitive. Very good. You got that sort of chain going on, linking things together. That is the transitive property. Very good. All right, here on number 8, I have 2 segments, AB and CD, being added together, and then that's equal to EF and CD. How come I can say AB is just equal to EF? What gets us subtract? Yeah, we could subtract CD from both sides and end up with this statement. That would be the subtraction property. Subtraction property of equality. Okay, I have this good statement here. PQ plus RS equals TV. But I also know that RS is the same as WX. And so they took the same thing, but what changed? Yeah, they substituted in place of RS, they traded out RS and plugged in the WX. What allows us to trade things out? Substitution. Very good. Substitution property. So we're taking one thing out and putting the equal thing in. So that is a good one to know. All right. So here we have LP is equal to PN, so I have 2 segments that are equal in length. And I know that LP and N are collinear. They are all in a straight line. How come I conclude that P is the midpoint? On both sides. We got 2 equal things. Definition of midpoint. Yeah, it is the definition of midpoint. It goes both directions. So this is satisfying all the conditions of being collinear and equal lengths. So we must have a midpoint. Okay. If congruent, then things are equal. What is that? Definition of congruence. Yeah. Definition of congruent, we could say if they're equal, then we have a double angle means congruent. That also works. If you want to do it in symbols, that is totally fine. Once you get used to it, definition of congruent isn't too hard. Okay. Look at number 12. What changed? They are subtracting DE from both sides, so it disappears on the left, just leaving the CD, and then on the right we have CE minus DE, so they are using the subtraction property. Very good. Subtraction property. Subtraction property of equality. And it's fun. So much fun. Yay! All right. What's going on in number 13? Yeah, very good. The division property. You'll notice we started with 2xy and we ended up with an xy. What do we have to do? We would have to divide both sides by 2. And so that is how we get rid of that 2 in front. That would be the division property of equality. Division property. What about 14? Transitive. I'll go with transitive. Again, we're sort of creating a chain link here. RS is equal to ST, and ST is equal to 2UV. Now, is substitution wrong? It is not, because it is exactly the same thing. That's why transitive works, because of the substitution property. But yes, either really would work here, but I would go with transitive. We have short and sweet statements, got this little chain link going on. So then we have RS is equal to the ending thing. We got the beginning and we got the end. I would say transitive. But substitution is also not incorrect. All right. So now that we've played around with those things, we're going to apply them to our segment proofs, which we still have like over 40 minutes to go, right? That's great. Okay. So we're going to try some segment proofs here using what we know. Let's see. Again, we are trying to prove that 2 DEs is equal to the whole segment. All right, if I double the length of DE, that's going to give me the whole segment. That's kind of interesting. And the only thing we're starting out with is that E is the midpoint of DF. E is the midpoint. What is my reason for E is the midpoint of DF? Given. All right, so always a good place to start with the given. All right, tell me, ladies and gentlemen, what do we know if E is a midpoint? We get 2 congruent pieces. If E is a midpoint, I know right off the bat that DE is equal to EF. And look at what's the next statement here? DE is equal to EF. How do we know DE is equal to EF? Definition of midpoint. And this is pretty common. They told us we had a midpoint. So what do we have to do? Say what that means. Okay? Please mark your pictures. It makes life super duper easy. Okay, so I have this statement that DE is equal to EF. And when I look at the next statement, I started with the DE, and what changed? They added, what did they add to both sides? Yeah, they added a DE on both sides of the equals. So they added DE to both sides. What property is that? The addition property. Addition property. They are adding the same thing to both sides. All right, so what is DE plus DE? 2DE, yeah. So DE plus DE combines and becomes 2DE. What do you suppose we're going to call that? Combine like terms, yeah, or simplify. Either one would work. Combine, simplify. I'd probably go with simplify, but either one would work.
Any 8th graders that need their picture taken or retaken, please go to the auditorium lobby, 8th grade.
So you'll notice at this point, you can see in our proof statement, we have 2DE is matching what we're trying to prove. So we've got the left side where we want it. And then, so we need to figure out how do we go from, hey, DE plus EF equals this DF. That's how we're trying to get there. So let's see what they did next. They said, hey, DE, which is this little segment, plus the other little segment equals DF. What property says this little piece plus this little piece equals the whole thing? Yeah, little piece plus little piece equals the whole thing. That is the segment addition postulate. Segment addition postulate. Little piece plus little piece equals whole thing. All right, so then we have, again, that 2DE matched up, so that was good. We had the left side of what we're trying to prove. And then we had the right side was 2 pieces, but we really wanted it to just say DF. So what did we do here with this DE plus EF? We combined, we replaced them with what they're equal to. So what is that called when we replace something?
Substitution.
Substitution, yep. So instead of DE plus EF, we replaced it with what it was equal to. So we could call that substitution. I would call it substitution. Oh my God, I can't spell this morning. Substitution. Oh my God, S-U-B, I don't know. I don't know. I'm just going to leave it at Okay. Substitution. Transitive would also work, but it's not, I don't know. I think it's more substitution. Yes, sir?
Couldn't you just jump to 3 to 6, DE plus D, D2, and then, yeah.
So you can't just jump, and that's the whole problem with proofs. You have to have a logical reason for every single step. And if you can't explain it in one reason, then you can't do it in one step. Okay? So you have to lay out all the little details, and that's what makes these proofs challenging. Yes, sir?
Never mind. I think
You got it. Yeah. So every little thing has to be justified. And segment proofs, I think, are the hardest proofs. We're going to do triangle proofs in the next unit or the unit after. I don't remember. And they're a little more cut and dried. They sort of work out a little easier. I think segment proofs are probably the hardest. But yeah, every single step has to have a reason. And so while in your mind we can jump there pretty easily, DE plus EF, again, has to be explained. Why is DE plus EF the whole thing? Why is it? You have to state it. Okay, and so that's what makes it hard. All right, let's try another here. Number 2. All right, we have given that segment KL is congruent to segment LN, and LM is congruent to LN. That is given to us, and they wrote that both things down in that first step there. I want to go ahead and mark my picture. I think it's really important to do that. So I'm going to use a couple of colors. KL is congruent to LN. KL, segment KL is congruent to LN. Hey, those two are congruent. I marked them with green tick marks. And then, let's see, LM is congruent to LN. LM, hey, that one's congruent to that one. I marked that one in red so I could see the distinction. Interesting. All right, how come we went to equal sign? What allows us to switch from congruence to equals? Definition of congruent. Definition of congruence. That all we're doing is trading out the congruence for equality. We can do a lot more when we're in equals mode. Okay? All right, let's see. Interesting. When I look at this big long chain here, KL is equal to LN, and LN is equal to LM. Ah, very good. How come I went from KL right to LM? That is absolutely the transitive property. So if I rearrange this, you can imagine if I wrote KL is equal to LN and LN is equal to LM. Can I jump from KL right to LM? You see the chain? Yeah, that's the transitive property. All right, sort of substitution, same thing. All right. So now we know that KL is now congruent to LM. So these two segments now are both the same. And if we have two equal segments with the point in the middle, what must we know? It's a midpoint. Yeah, L must be a midpoint. Why? Definition of midpoint, yeah. The nice thing is for most of these proofs, you're just having to fill in the reasons. Again, I think these are harder than what we'll be doing later with triangles, so it's kind of a mind warp. All right, let's try another. Okay. We have a couple things here to start. PQ is congruent to TQ, and UQ is congruent to QS, and you can see those are written in the first line here. So that is our given. And I'm going to go ahead and mark my picture. PQ is congruent to TQ, so I did those in green. And I'm going to mark these others in red. UQ is congruent to QS, just so we can see that they're different there. Different, but, okay. All right, once again, what allows us to trade between congruence and equals? Yeah, no. Definition of congruence. Definition of congruence. All we're doing is everything matches except we have congruence changed to equals. That's the only difference. We're trading between congruence and equality. Okay, so now we're in equals mode. Let's see, statement 3 here, PQ plus QS equals PS. PQ plus QS equals PS. What allows me to say PQ plus QS equals the whole PS? Yeah, segment addition postulate. Very good. And the same thing over here. TQ plus QU equals the whole thing. So it's really important when you're looking at your statements, looking at the picture as well, so you get an idea of what you're looking at. And if I can kind of model it, I can see it out, say, oh, I'm on one segment and then another little piece, and that equals the whole thing. That's the segment addition postulate, okay? All right, so then let's see. If I compare 3 and 4, looking, I see PS matches up above and QS matches up above. And yeah, very good. The PQ was traded out for a TQ.
Any 7th graders who need pictures taken or retaken, they go to the auditorium lobby, 7th graders.
And that came, they pulled from step 2 there, saying, hey, those two things are equal, so I'm going to take one out and put one back in. That is substitution. Very good. There we go. That's how you say substitution. Okay. All right. Once again, looking at the second half here, the TQs match up and the ending TUs match up, but what traded out? Yeah, QU and QS, and that came from right here. QU and QS are equal, so they took the QU out and put the QS back in. So that is, again, substitution. All right. And now, when you're looking at steps 4 and 5, TQ plus QS, both those things are the same. And so we can say, hey, PS is equal to TU. What allows us to say PS is equal to TU? Transitive, yeah. Or you could use substitution. I'd use transitive here. PS is equal to this thing, and that thing is equal to TU, so they must be equal to each other. Transitive. Got this big whole chain of equal signs going on. Interesting. Okay. All right, and then once again, what's the only thing that changed here in step 6 and 7? Yeah, the congruent statements here. So what allows us? Definition of congruent. Yep, that's switching between equals and congruent segments. Okay. Interesting. How you doing with this? Is it okay? It's too much. So much repeating. It's a lot. We're just going to do one more, and we'll save the other 2 for tomorrow. It is a lot of explaining that sometimes goes in extravagant detail. I'll say that. Okay. All right, last one for today. All right, let's see. We have K is a midpoint of JL, and M is a midpoint of LN. and those are both given statements right off the bat. We also have the given statement that JK is equal to MN. So JK is equal to MN, and you can see that is down here. So that is another given statement. So she has separated the two parts of the given statements, which is sometimes we do. So we got a couple given statements, but let's go back up to our midpoint statements here. It says K is the midpoint. If K is the midpoint, how come we jump to JK is equal to KL? Why do we know that JK is equal to KL? Because of? Definition of midpoint. So again, we gave you the word midpoint. We want to describe what that means. Okay, if we said, hey, here's midpoint, what do you know from it? That's the next step. All right, and so again, then because M is the midpoint, we also know that LM is congruent to MN. Again, that is definition of midpoint right there. Okay. All right, so then they say in red, JK is congruent to MN. That was given to us. And then, let's see, what changed? I see MN is equal to KL. How do we get there? MN turns into KL. How do we?
It says that it's equal to JK, and then JK is equal to KL.
All right, so MN is equal to JK, and then JK is equal to KL. So we're going MN to JK to KL.
Last interruption, this is last call for anyone who needs pictures taken or retaken. Please go to the auditorium lobby at this time. Last call.
So transitive or substitution, yeah. I'm going to use that one there, it looks like. So MN to JK, JK to KL. I think transitive, she has written down substitution, but I think transitive works here. You know, MN to JK and JK to KL, that's exactly what we're saying right there. So there's that sort of chain going on. Substitution is not wrong, okay? It is substitution. That's exactly what's happening here. Let's see, does the same thing happen for MN? Can we make a chain here? Starting with LM, that's the same exact thing. So I don't know why we needed to restate that maybe we don't. Okay, so that is just the exact same thing as above, so I don't really need to state anything for that. Okay, all right, so then let's see. I want to mark up my picture here a little bit. MN, that's this segment right there, is equal to KL. So those two things are congruent. And then LM is equal to, oh, MN. Hey, look at that. Interesting. How do we get here? How do we get LM is equal to KL? Transitive again, absolutely. Here we are. We've got the LM that's going to MN, and then MN is going to KL. That again, transitive. Crazy, huh? And so when you look at the picture, you can see how we overlapped one. That's a good clue that that's transitive. Okay. And then the last step, let's see. Oh, what allows us to go from 5 to 6? What changed here? Yeah, symmetric. We just spinned it around. The symmetric property. And then what changed from 6 to 7? Yeah. Definition of congruence. We went from equals to congruent pieces. All right, a little bit crazy. Again, I think these are more challenging than we'll see later on, but all right, good job, you guys. Let me pass out a little work you can get started.